In our last video, we talked about evaluating composite functions where we were trying to get a numerical answer. This time we're going to try and find a composite function which will be an equivalent function to the composite. Let's see if I can do an example here and explain to you what I mean. So f of x is equal to 6x plus 11, and g of x is equal to 5x minus 1. And I want to find f of g of x. Remember that I said before that the composite is the same thing as plugging the inner function into the outer function. So I'm going to leave the f alone, and I'm going to replace g of x with the function that it's equivalent to. And now I'm going to write f with a set of parentheses for its variable. And I'm going to plug in that composite or in that inner function, and I'm going to evaluate and simplify here. So 6 times 5x minus 1 times 6. 6 times 1, excuse me. 6 times 1 plus 11 is a 30. X minus 6 plus 11 is 30x plus 5. And this is my composite function, f of g of x, where the entire composite now, instead of being done in 2 steps of having to find f of x and then plug it into g of x, if I wanted to find f of g of some number, I could just simply plug it in to this composite function, and I would get the same answer. Let's go ahead now and do that with f of x is equal to 3 over x minus 5, and g of x is equal to 7 over 3x. So let's find f of g of x. So I'm going to write down f, and in parentheses, I'm going to insert g. I'm going to pay attention to the fact of the domain here that x can't be equal to 0. And then I'm going to try to get rid of this complex fraction here. The way I'm going to do that is I'm going to make a common denominator and multiply by 3x over 3x. So this is 3 over 7 minus 5 times 3x divided by 3x. 7 minus 15x divided by 3x is 3 divided by 7 minus 15x over 3x. 3 times 3x over 7 minus 15x. This is a 3 over 1 is going to be equal to 9x over 7 minus 15x. X can't be 0, but also 15x can't be 0. So negative 15x can't be negative 7, and x can't be 7 over 15. So we have restrictions here that x can't be 0 or 7 over 15. We weren't asked to find the domain, but it's important to pay attention, especially with rational functions here, to what the domain of my composite is. So it's equal to 9x over 7 minus 15x, as long as x is not equal to 0 or 7 over 15. At 0, there's going to be a hole in the graph. At 7 over 15, there's going to be a vertical asymptote. All right. for number 15, f of x is going to be x minus 2 over 7. G of x is equal to 7x plus 2. We want to find g of f of x this time. So I'm going to write down g. I'm going to insert f, and 7 will divide out with the 7. And then the plus 2 and the minus 2 will zero out, and I'll be left with x. What just happened is a very special case, and we're going to talk about that one more, but we're very interested in something later that I won't give it a name right now, but we're interested in something where this and this happen, and if those both happen, then f and g will have a special relationship with one another that we'll get a video about coming here soon. But hold that in your mind. Anytime that you see a relationship here where you find the composite function and it comes out to just be x, that's going to be an interesting one that you're going to want to think about more later. So f of x is going to be 7 over x minus 5. G of x is going to be 3 over 4x. And f of g of x, I'm going to write down f. Since it's the outer function, we're going to plug in g. We're going to pay attention to the fact that x can't be 0. Now we're going to clear the fractions, and I'm going to do that a little different than last time. I'm going to multiply everything by 4x. It's going to give me 28x over 3 minus 20x. It does the same thing as making a common denominator and then multiplying by the reciprocal. And so I've got 3 minus 20x can't be 0. So 20x can't be equal to 3. And x can't be 3 over 20. So x can't be 0 or 3 over 20. Right? Okay. 17 here. F of x is equal to x minus 9 over 4. And g of x is equal to 4x plus 9. We want to find g of f of x. So we're going to write down g. And f is going to go on the inside. And this is going to be x minus 9 plus 9. And there it is. It happened again. How interesting. So let's pay attention to this one and that one, right? Those might be something special to come back and talk about later. F of x equals the square root of x plus 7. G of x is equal to 8x minus 11. And I want to find f of g of x. I'm going to write down f with a set of parentheses for the x. And inside there goes g. And we have 8x minus 4. We can simplify that a little bit because there's a perfect root, a perfect square, like so. and I can do that. So this is going to be 2 root 2x minus 1. Now we've got f of x equal to 4x squared plus 3x plus 4. And g of x is equal to 3x minus 6. So we want to find g of f of x now. So we're going to write down g. And inside for the x there goes f. We're going to distribute 12x squared plus 9x plus 12 minus 6 is 12x squared plus 9x plus 6. And our last problem for this video, the f of x equal to x squared minus 4, and g of x is equal to x squared minus 1. F of g of x, we're going to write down f, big set of parentheses there for its x, and inside goes g. Remember, when you're squaring a binomial, this, we're going to need to FOIL. So first, outside, inside, last, be x to the 4th, because when I multiply like bases, I add the exponents, minus x squared, minus another x squared, minus a negative, or a negative times a negative, that's going to be a positive, x to the 4th, minus 2x squared, minus 3. All right, that's it for this video. We'll come back next time and we'll talk about the next part of this, which is one-to-one functions, and then we'll put these ideas of those things together, and we'll talk about the special type of function that I have an asterisk next to here. If a function is one-to-one, and if the two functions are one-to-one functions and I can compose them and get x, then it has a special relationship, but we're going to have to talk about what a one-to-one function is before that. So that'll be our next video. See you for that.